Given this equation, we are asked to solve for its general solution. To solve it, we first transpose this term to the other side and distribute the x to the terms inside the parentheses. So it will become like this. And we integrate each of the terms in the equation. We label each terms as A, B, C, and D so that can solve each individually. To solve for A, which is 2 sine 3x dx, I'm getting the integral of it, we first take the term inside the sine as a single term. So we let u is equal to 3x, and by getting its derivatives, it becomes du is equal to 3dx, and by dividing 3 by both sides, we have 1/3 du is equal to dx. Substituting it to the equation, we get 2 the integral of sine squared u du. Now the sine squared has an identity which is sine squared u plus cosine squared u is equal to 1. Rearranging the terms in it and substituting, we get 2 multiplied by the integral of the quantity 1 minus cosine squared u du. Then distributing du to each of the terms inside the parentheses and integrating each of the terms, we get 2 integral of du minus 2 the integral of cosine squared u du. We label this as I and double I. Solve for it. For I, we get the integral of du, which is just equal to 2u. Now for double I, we get the negative 2 times the integral of cosine squared u du. Now cosine squared u, when you integrate it, it has the identity which you can substitute, which is equal to 1 plus cosine squared cosine 2u over 2. So by substituting it with the cosine squared here, we get 2 multiplied by the integral of 1 plus cosine 2u over 2 du. And by factoring out the 2 in the denominator, which cancels out with the 2 outside, it becomes just -1. And by distributing du to all of the terms inside, we get negative the integral of du minus the integral of cosine squared u du. Now we have to make 2u here into a single term, so we substitute it. We let v is equal to 2u, and then getting the derivative dv, which is equal to 2 du. By dividing it by 2 on both sides, we get 1/2 dv, which is equal to du. And substituting it, we get 1/2 negative the integral of du minus 1/2 the integral of cosine v dv. Now the cosine of the integral of cosines is just equal to positive sign, so the integral of du is just equal to u. So getting the integral of all the terms, we get negative u minus 1/2 sine du into u. Going back to the original terms, we get 2u minus u minus 1/2 sine 2u. Now substituting the value of u, which is equal to 3x, we get 6x minus 3x minus 1/2 sine 6x. Combining the similar terms, we get 3x minus 1/2 6x. This is the solution for A. To get the solution for B, which is equal to the integral of dx, which is just simply equal to x. For the terms in C, which is equal to the integral of cosine of 6x dx, as we have done earlier, we just substitute the term 6x with u. So we let u is equal to 6x, and then getting the derivative du, which is equal to 6 dx, and dividing it by 6 on both sides, we get 1/6 du, which is equal to dx. Substituting it, we get 1/6 the integral of cosine u du, and then the integral of cosine, which is just equal to sine, so we get 1/6 sine 6x. So this is the solution for C. For part D, we get 2 the integral of dy. the integral of y is just equal to y, so we immediately get to y. Combining all the solutions we had earlier, x 1/6 sine 6x and dy 2y and 3x minus 1/2 6 sine 6x, we get 3x minus 1/2 sine 6x plus x plus 1/6 sine 6x plus 2y plus c. We add the c. The c is an essential part when integrating differential equations. By combining similar terms, we get the final solution, which is 4x minus 1/3 sine 6x, which is equal to 2y plus c. So we have the general solution for the given equation.